Moving on to section 3 of chapter 3, function notation. Has anyone ever heard of function notation? You've probably seen it before. You probably just didn't know it was called function notation. So let's discuss it real quick. You know that a linear function can be written in the form y equals mx plus b. We talked about that the other day, right? If something's a linear function, I can write it in the form y equals mx plus b. Do we remember that information? Okay. By naming a linear function f, you can also write the function using function notation. So this right here is function notation. Did a whole lot change from y equals mx plus b to that? No. What's the only thing that changed?
The f with the x thing.
The f with the x, right? The y changed to that, right? So we would read this as f of x. It's not f times x, it's not fx, it's f of x. Everyone say f of x. F of x. F of x. So I'd say f of x equals mx plus b. Okay? Everyone see that? It's just a function f at the given value x. So f of x. The notation f of x is another name for y. So we're just treating f of x like y. It's just our new y. Treated the exact same though. Okay? If f is a function and x is in its domain, then f of x represents the output of f corresponding to the input. So instead of y being my outputs, it's my f of x as being my outputs. Because remember, we're treating f of x like y. You can use letters other than f to name a function, such as g or h. You could see g of x, h of x, s of t. Still just treat it like y. Does that make sense? It's just another way to write y. Okay? Any questions, any confusion here? Am I good to move on? Okay. Example 1. Evaluate f of x equals negative 4x plus 7. Any idea? Or when x equals 2 and x equals negative 2. Any ideas what I'm going to do here? Substitute what for what?
X for 2.
Yeah. Yeah, I've got two problems here essentially. I've got to substitute my 2 in for x equals 2, right? So how I'm going to do that is I'm going to replace all my x's, including in the f of x, with 2. So now I'm finding the function when x is 2. So I'm finding f of 2 now. Now I'm just using my order of operations. What comes first, multiplication or addition? Multiplication. So what's negative 4 times 2? Negative 8. Bless you. Negative 8 plus 7 gives me negative 1. So f of 2 equals negative 1. So if I were to write this as an ordered pair, what was my x value that I used? 2. What's the corresponding y value or f of x value that I got? Negative 1. So it'd be 2, negative 1. Okay? You don't have to write it as an ordered pair. I was just showing you that we're still just treating f of x like y. Okay? So that negative 1 is my y value, my f of x value. Questions on that one? Now I need to do the same thing with negative 2. So just replace all my x's with negative 2. Same steps here. Negative 4 times negative 2 gives me positive 8. And 8 plus 7 gives me 15. So my f of negative 2 is 15. So if I were to write it as an ordered pair, what's my x value? Negative 2. What's its corresponding y value? 15. We okay with that? Just treating f of x like y, right? You guys have done this, evaluated a function for a given value of x, when it was y equals mx plus b. Now we're just doing it with f of x, function notation. Questions on example 1? Okay, let's move on. Okay, example 2, interpreting function notation. Let f of t be the outside temperature, degrees Fahrenheit, t hours after 6 a.m. Explain the meaning of each statement. Does everyone understand what we're doing? Gives us 3 different statements. We're going to explain the meaning behind each statement given this information up here and what's in our problem. So for letter A, I've got f of 0 equals 58. What did they replace t with? 0. What does t represent? Hours after 6 a.m. So how many hours after 6 a.m. is it right now? 0 hours after 6 a.m., right? Because that's what they replaced the t with, was 0. So what time is it on letter A? 6 a.m. So what's it saying if it says f of 0 equals 58? There we go. Did everyone hear that? It's 58 degrees Fahrenheit at 6 a.m. Does everyone understand how we got that? The t was replaced with 0. So it's 0 hours after 6 a.m., so it's still 6 a.m. So it's saying the temperature at 6 a.m. is 58 degrees Fahrenheit. We good with letter A? Okay. Letter B. F of 6 equals n. F of 6 equals n. What'd they replace the t with? 6. What does t represent? Hours after 6 a.m. So what time is it in this scenario? 12 o'clock. Noon, right? 12 o'clock p.m. So what's it saying if f of 6 equals n?
12 o'clock.
Say what? What's the temperature at 12 o'clock? In degrees Fahrenheit. It's 10 degrees Fahrenheit at noon. And that's what the statement's saying, right? So I interpreted it based on the information that I was given. Do I know what n is? No. But that's all the information I was given. That's all that I can say about it. Okay? Questions on B? Letter C. F of 3 is less than f of 9. F of 3 is less than f of 9. Does someone want to raise your hand and take a stab at interpreting this statement? F of 3 is less than f of 9.
Hotter at 9 o'clock than it is at 3.
Does everyone agree with that?
Yes.
Okay. Wait. No. You said it's hotter at 9 than it is at 3?
The temperature is greater.
F of 3 is what time? 9 o'clock. Because it's 3 hours after 6 a.m. Right? Remember, T is the number of hours after 6 a.m. So F of 3 is talking about 9 o'clock a.m. Right? So the temperature at 9 o'clock is less than the temperature when? 3 o'clock p.m., right? 9 hours after 6 a.m. Yeah, that'd be 3 o'clock p.m. Does everyone see that? So don't think that F of 3 is talking about 3 o'clock. Right? It's talking about 9 o'clock a.m. So the temp at 9 a.m. is lower than the temp at 3 o'clock p.m. And that's what the statement's saying, right? Does everyone understand how letter C is saying that? Are we good with example 2, or do we have any questions or confusion? Okay. Example 3. For h of x, this is just function notation again, right? Instead of f, we're using h. We still treat h of x like y. For h of x equals 2/3 x minus 5, find the value of x for which h of x equals negative 7. Any ideas how we're going to approach this problem? For h of x equals 2/3 x minus 5, find the value of x for which h of x equals negative 7. Any ideas here? Yes. Substitute what for what?
Negative 7 for x.
Negative 7 for x?
H of x.
H of x, right? Be careful here. On example 1, it told us that x equals a number, and we plugged that number in for x, right? Here, does it say x equals negative 7? No, it says h of x equals negative 7. H of x is just our y value, right? So I'm replacing h of x with negative 7. Just like this. Does everyone see that? Just remember, it's not h times x, it's not hx, it's h of x. Keep h and x together for h of x. So we're just replacing negative 7 with h of x. Or replacing h of x with negative 7. My bad. Where do you think I'm going to go from here? Surely that can't be my answer, right? Say that again?
Solve it like an equation.
Yeah, solve it. I'm going to solve for what? X, because I'm finding the value of x when my y value is negative 7. Yep, I'm going to add 5 to both sides, trying to get x by itself. Negative 7 plus 5. Negative 2. Okay, how would I get x by itself now? Divide by 2/3. So what do we get? You can do this in your head or on paper.
In my head.
Yeah. You like keep, flip, change, KFC, you know? Come on now. What do we get? Did you type it in? Negative 3. So, the value of x when h of x is negative 7 is negative 3. So how would I write this as an ordered pair if I was asked to? Negative 3, because that's my x value. Negative 7, because that's my y or h of x value, right? Everyone got that? So this problem is very similar to our first example. Pay attention to what information they give you, though. Here, on for example 1, they gave us x values to plug in, and we were asked to find the y value or the f of x value, right? Here, we were given the h of x value, the y value, and we were asked to find the x value. Does that make sense?
Wait, how'd you get the negative 7?
That's what I was given for h of x. Right? So I found the x value when my y value was negative 7. So I found its corresponding x value. Okay? Questions on example 3? Can I move on?
Yes.
All right. Okay. Graph f of x equals 2x plus 5. We're not going to quite graph in slope-intercept form yet. That's going to be a different section. Any ideas how we're going to graph this? What?
How you find your order pair? Is graph from there?
Well, am I given an x or a y value?
No.
No.
Can you graph it?
Yeah, you can graph it. You can graph slope-intercept form, but like I said, we're not going to do that today. A table of values. I can create my own table of values, right? I'm going to have an x column. Do I have a y column?
No.
I have a what column?
FX.
F of x, not fx. F of x, right? Because f of x is being treated like my y value. Okay? What is this going to create when I graph it?
Ordered pairs.
Well, we're going to graph ordered pairs to create what?
A line.
A line, right? What's the domain of a line?
Courier continues.
So, and
What? I think I heard you say it. Well, it's my set of x values, but the domain of a line, a non-vertical line, does it ever stop going to the left? No. Does it ever stop going to the right? No. So what's my domain? All real numbers, right? So do you think it matters what x values I pick to plug in? No, because all the x values are a part of my domain. I just need to pick some x values to get my ordered pairs to see exactly where this line is going to be. Does that make sense? Okay. So, someone pick an x value for me to plug in, and let's keep it relatively small. Don't pick something crazy like 2,000, because that's not going to be on my graph. Okay? Let's try 7. Everyone knows how to plug in an x value. Plug it in for x, use my order of operations, right? So this will be 2 times 7 plus 5. Oops. There we go. 2 times 7 gives me 14. 14 plus 5 gives me 19. It's going to be a little off my graph. So let's try to pick a little bit smaller values here. Okay, I heard 2. And we'll do 3 next. Okay? So 2 times 2 plus 5. Does everyone see how we're doing this? Picking values, plugging them in to get our corresponding f of x values. 2 times 2 gives me 4. 4 plus 5 gives me 9. So 2 comma 9 is going to be an ordered pair. Is that going to be on my graph? Yes, it is. Right 2, up 9, put my point. Everyone good with that? Okay, let's plug in 3 now. 2 times 3 gives me 6. 6 plus 5 gives me 11. 3 comma 11. It's going to be a little off my graph. I might be able to squeeze it in there. Be up here somewhere. Okay, pick another value. 1. Plug 1 in. 2 times 1? 2. 2 plus 5? 7. 1 comma 7. Is that going to be on the graph?
Yes.
Right 1, up 7. Everyone seeing how we're doing this? I want you to have at least 5 points on your graph. Do I have 5 points yet? No, how many do I have? 3. I need at least 2 more. Okay? So what's my next x value, sorry, that I'm going to plug in?
-2.
I heard -2. Plug -2 in. 2 times -2? -4. -4 plus 5? 1. So -2, comma 1. That'd be left 2, up 1. And I want you to have one more on your graph because there's 4 points. I want 5. So raise your hand if you want to give me my last x value here. Jordan. 0. 0 is always a good one to plug in. I always like plugging in 0. It's pretty easy to plug in. Okay? 2 times 0. 0. 0 plus 5? 5. 0 comma 5. I'm not going left to right any. I'm just going up 5. Do I have at least 5 points on my graph? Okay, sometimes I'm a little bit OCD. I'm going to go ahead and plug in -1 as well. Okay, I got that missing point right here. I can't have that. So if I plug in -1, 2 times -1 gives me -2. -2 plus 5? 3. So -1, 3. Left 1, up 3. That's better. It's much better. Do I have at least 5 points? Yeah. Do I need to connect these points? Yeah. Yeah, I probably do.
Very straight line.
Thank you. Put your arrows on your line because that's going to go on forever and ever and ever. Okay? And there's my graph. Today, if it asks you to graph, I want you to use a table of values. Okay? On your graphs today, it should be all linear functions. So your domain should be all real numbers. So you should be able to pick any x values you want. But you need to be a little bit wise about picking your x values, right? You don't want to go way past the numbers that are on your graph. Those numbers go on forever and ever and ever, but to make life easier, we make graphs smaller and more condensed. So that's what I would do if I were you. Any questions on how we graph this? Can I move on? There you go. Page 127, numbers 1 through 27 odds. This will be due Friday. The 28th on Canvas.
He's going to hall pass just to go see if my ID is in the 2,000 locker.
Ask me in a second. Okay. Do we have any questions, comments, concerns about the notes before I end the recording?